in the regions of our solar system. This object is even larger than Pluto, but has a similar orbit. It goes through this Kuiper belt and is traveling even farther out there. This astronomer's name was Michael Brown. And when he discovered this, because it was larger than Pluto and had a similar orbit, he figured, well, if Pluto's a planet, I guess I'll call this our 10th planet. And he gave it the poetic name 2003 UB313, which is what happens when you let astronomers name stuff. Now, he wanted to give it a more majestic name, a name that would be a little bit easier, so he gave it a nickname, an unofficial nickname. And he wanted that nickname to represent the Greek pantheon, like all the other planets are named in. And he also wanted to incorporate the symbol for the Roman number 10, because if this is our 10th planet, the symbol for 10 is, does anybody know what the symbol for the Roman number 10 is? X, that's right. And so, taking all of that, he named this, unofficially of course, he named this planet Xena, for the Warrior Princess TV show of the 1990s. Ah, and I see that we watched it too. Oh yeah, we all did that. Well, in 2006, the International Astronomical Union got together and they decided, first off, we're not going to call it Xena, which is kind of a bummer. Instead, they gave it the official name of Eris, which is the Greek goddess of discord and strife, because it was this object that brought into question what we're going to define as a planet. You see, if Eris is a planet, and if Pluto's a planet, if we were to take the idea that any big ball-shaped object orbiting around in our solar system is called a planet, we'd have something like 65 or 85 planets in our solar system, somewhere in between there. So how many people would like to take that astronomy test? One person would like to take, 2 people would like to take that astronomy test. The rest of us want to have our weekends back. So they decided, for the very first time in history, to come up with a single scientific definition of what a planet was. Believe it or not, before 2006, you can get your definition for a planet from a dictionary, a geology textbook, an astrology textbook, whatever you wanted. All of those definitions were equally valid. But in 2006, the International Astronomical Union decided, once and for all, that a planet is an object that orbits around a star. It is an object large enough to establish its hydrostatic equilibrium, which is a big way of saying it's shaped like a ball. And the third definition for what a planet is that a planet must have cleared away its path around the sun. A planet cannot simply be one rock in a huge debris field full of rocks. And this is where Pluto left out, and this is where Eris was left out. So today, we do not call Pluto a planet. What do we call Pluto today? What do we call it? Dwarf planet, yes. Or Plutoid, which is the more fun name, which is yet to catch on. So where Pluto used to be the runt of the planets, it's now king of the dwarf planets. And just to give you an idea, I really want to emphasize this. When we say Pluto, trying to call Pluto a planet, Pluto is so small, if you were to pluck it out of the sky and set it onto planet Earth, you could easily place Pluto in the middle of the continental United States without crowding any of our borders. Well, now we are going to leave the planets of our solar system and the Kuiper belt and travel even farther out into our solar system, you might say, to yet another debris field surrounding our sun. This one is called the Oort cloud. And compositionally, the Oort cloud is very much like the Kuiper belt, except it's sitting at an extreme distance from our sun. It actually goes out as far as a light year. Now, occasionally, an object from the Oort cloud will fall out of its orbit and dive in towards the middle of the solar system, towards our sun. And as it passes the orbit of Jupiter, it's going faster and faster, and it's getting more and more energy from the sun, causing the surface to boil. And as it boils away, material from the outer surface chips off and drags behind it as a huge debris field. And this debris field can stretch out for millions of miles. What do we call an object like this? A comet, that's right. And this is why astronomers get so excited when you see a comet, because a comet is like a postcard from this very extreme region of space. It's much farther than we can easily look at with our telescopes, and much too far to ever send a spaceship to explore. So now we are going to leave the Oort cloud and travel in interstellar space, the space in between the stars. Does anybody know the name of the nearest star to our sun?
Alpha Centauri.
Alpha Centauri, that's right, which is 4.5 light years from our sun. In fact, can you see it right there? See if I can get a little bit closer to it. There, you can see, you can actually see, who's flying past. There's Alpha Centauri right there, and next to it is another object called Proxima Centauri. It's actually like a little binary. So Proxima is just a little tiny, it's actually a trinary, 3 stars orbiting around with the same gravity. And Proxima is just a little bit closer, but the whole system is called Alpha Centauri. And that is 4.5 light years from our sun. Now, just to give that, I wanted to give that, that's our nearest stellar neighborhood. Now, as we go even beyond our closest stars, we see a grid appear. Now, this grid is a science visualization tool that astronomers use to define an 80 light year radius around our sun. And the reason we like to define this 80 light years is because this is the distance traveled by the very first powerful radio signals to leave our planet. Put it another way, if there was an alien spaceship sitting out here on the edge of this sphere, and it was pointing an antenna towards our planet, trying to pick up any signs of radio intelligence coming from our planet, that spaceship would just now be learning about the 1936 Olympic Games. Because that was the very first radio signal that was powerful enough to break free of Earth's gravity and travel out among the stars. Now, if there was anything inside this sphere, the closer you get to our sun, the more recent broadcasts you're going to hear. Because we have continued to send radio signals out into space, traveling at the speed of light. And the closer you get to our sun, the more recent radio broadcasts you're going to hear. However, once you go outside that 80 light year radio sphere, you are now beyond the distance traveled by any of our radio signals. And what that means is that all of this space out here that's outside that sphere has no clue what's going on with Celebrity Apprentice tonight. I can appreciate that. Now, once we continue out beyond there, we will eventually come to the rim of our galaxy. Who could tell me the name of our galaxy? The Milky Way, that's right. 200 billion stars rotating around a gravitational center, extending across for 100,000 light years. And to keep things in perspective, you are right here. That's where we fit into everything. The Milky Way is our local city in space. This is our galaxy. And once we move beyond the Milky Way galaxy, we are now traveling in intergalactic space, where there are no stars, no planets, no comets, no moons, nothing, until we come to our nearest galactic neighbor. Who can tell me the name of the nearest galaxy to the Milky Way? The Pleiades? No.